Welcome to the tutor. My name is Joey Monday, and I will be your tutor for Digital System 2 along this semester. So today's video is an introduction to the subject, but it's not gonna be that introduction because we already gonna start with our chapter 7. So we're gonna choose one part of chapter 7. So chapter 7, we're gonna make 3 lessons about chapter 7. So I'm really happy to be your tutor. So there will be a WhatsApp group provided for the subject for the register student. If you have any question, you can always try to ask those questions directly to me. So what are the points that we are going to discuss? We are going to do an introduction of chapter 7. We are going to discuss about latches, which is just one part of the content that is in chapter 7. About the introduction, we're gonna talk about the 2 categories of bistable device, and the 2 categories are our latches and then our flip-flop. So today's lesson is gonna be all about latches. So you really gonna make sure that you master these latches on this video. And then when you talk about bistable device, we have a device which has only 2 states, and the 2 states is only set, or set is the same as 1, or you can say reset. Reset it's 0. So those bistable, what are those bistable devices? Your latches and your flip-flop. But the 2 have 2 states, set and reset. And therefore, the main difference between the latches and the flip-flop is that the method they use in order to change their state. And the states that we discuss, we say we have only 2 states. Those states is what? Your set and as well your reset. So by the way the 2 devices change their state from set to reset, that's the only difference between the 2. But today we want to focus our lesson on latches. Okay, therefore let's start with our first part of chapter 7. There will be a second part and as well the third part, then we'll finish with chapter 7. What are the type of latches that we can keep in mind? We have 3 types. The first one is the SR. SR. What you mean by SR is that S, it means stand for set. R stands for reset. So these are this is the first type of latches that we have. It's a SR latches, a set and reset latch. And then the second one we're gonna discuss, the gate SR latches. Is the same as the first one, but the difference is now that we have a gate. Okay, and the third one is gonna be a gate D latches, which is different from the 2, but they are basically similar. Okay, so for this lesson we're gonna be using screening video, and as well there will be a board where I will do some example for you to understand some of the concepts when it comes to the test or problem solving. Okay, so the first type that we're going to discuss is our SR set reset latch. And then for this type, by the symbol, this is the symbol that we are going to use. When you see this symbol, know that this is your SR latches, set and reset. But this is called to be a active I. Okay, active I, as you can identify, it's only SR. This is an active I SR. Okay, so when it comes to these latches, they are basically made of gate, like your NOT gate, OR gate, and AND gate. But this is an AND gate, so they are made of a OR gate, so that the combination of the 2 is gonna make us get some different output. Okay, So what happened with these SR latches? It means when you have a 0 and 0 on a 0 on your set and 0 to your reset, if you have a 0 here and then you have a 0 on your reset, okay, there will be a no change of state because you have 0 0. The output will be what? 0 0. Okay, so we're gonna get a 0 0 output. Okay, and then in the second case, when you have a 0 on the set, you have a 0 on the set, and then you have a 1 on your reset, a 1 on your reset. Okay, the output is going to be what? It's reset. Why reset? Because we're gonna have a 0 on the high output and a 1 on the low output. Can you see? So what we need just to keep in mind is just the configuration. If I have 0 0, I must know that there is no change. But when I have 1 0 1, which means I have a 0 to a set, a 1 to a reset, I'm going to reset. If I have 1 on the set, 0 on the reset, I'm going to set. Okay, but if I have a 1 1 on both of them, this is gonna be invalid. Okay, so these are our input. Our output will be considered this. Okay, and to determine our output, we look at our input. If I have a 0 0, I have a no change. If I have a 0 1, this one on the reset, it means it's reset. Okay, to reset it means is at 0. The output will be 0. Okay, and then if you have a 1 0, your output will be set because you have a 1 on your set. But if the two are 1 1, you are going to have an invalid output. Okay, and then another type of a SR latches, we have a active low. Okay, with an active low, basically what happened is now we have a inverse. Okay, this little circle here, it means it's inverse. Inverse. This bar on the S, it means inverse. Can you see? Can you see that? The difference between the two is that now with an active high, when you have a 1 on reset, you reset. When you have a 1 on set, you set. When you have 1 1, it's invalid. Okay, but now because we have this circle here, it means we're gonna do the inverse. When I have a 0 on the set, I set. When I have a 0 on reset, I reset. When I have a 1 1, it's no change. But when I have 0 0, it's invalid. Okay, so the difference between the active high and the active low is just by the way that with the active high, in order for me to set, I need to have what? In order for me to set, I have to have a 1 and 0 as input. 1 on the set, 0 on the reset, I set. In order for me to reset with the active high, I need to have what? A 1 on the reset and 0 on the set. So I reset it. And then when I have a 1 1, it's invalid. 0 0, it's no change. But when it comes to your active low, when you have 0 0, because it's an inverse, it's invalid. Can you see? So here it was 1 1 invalid. For the active low, it become 0 0 invalid. In order for you to set, you need to have what? A 0 and 1 on your reset. Then you do what? You set it. So if you want to reset it, you need to have a 0 on the reset and as well a 1 on your set. Then you reset it. If you have 1 1, then you have what? No change. Okay, because if you remember the concept in digital one, it was all about you have this is an inverter. What happened with an inverter? A 0 change to 1, a 1 change to 0. Okay, so that's the difference between the two. Okay, and as we said, a set represents 1, a reset on the output represents 0. A set represents 1, reset represents 0. Okay, so we're gonna do an example on it on our whiteboard. So we're gonna have a look on example for the kind of question that may be asked to you in the test. So most of the time they use a diagram, a block diagram for you to solve and to find out what will be the output. Okay, so as you can see, this is our baseline. The baseline is here, and then for this one the baseline it's there. When it comes to the output, we only consider this Q. Okay, so the first thing you should do here is to set your timing, because every place when there's a change in time in state, you need to take it as a timing. Like for instance, on this point you can see that it went down, then we go with it down. Okay, so this side is gonna be our initial state, initial time. And then when you come here, you cut it again when there is a change, and this will be the first clock. And then when you come again, you see on the R, on the reset, there's a change in timing as well. So you go with it up, you go with it down, to say that this will be our second clock. Okay, and then you go, you check again, everywhere place there is a change, you pick it, go with it down, you say this will be my third clock. And then you check again, you can see that here there was a change, so that you take it, you call it to be the fourth clock, and then the fifth clock, and this can be continued according to how your graph will be. Okay, so now the question is, once you come here, you check, you can see that on the initial state, they say, for instance, this was 0, what's reset was low. Okay, so we have a low there. Okay, and therefore we come on our first clock. First clock, you come here, you put your, here it's 0, as you can see, and then here you have a 1. A 0 on the set and a 1 on the reset. It means your output will be what? Reset as well, because it reset. So you're gonna have a 0 on the output. Okay, so now you come here, you see you have a 1, and then you have a 1. What do you say about 1 1? It means it's gonna be what? Invalid. So you're gonna have an invalid output. Okay, and then you come, you check, you see you have a 1 on the set, 0 on the reset. Your output will be what? Set. So this will go up. Okay, and then you come, you check again, you see you have a 1 1 there. What does that mean? It's invalid. There is no change there. Okay, and then you come again, you check, you see that you have a 0 and then a 1 on the reset. What does that mean? You have reset. It's gonna go back to 0. So that's how you play around. The first thing you do is you pick every point where there is your clock is changing, your set and reset is changing the state. So you pick them, and you know that the first clock, second, third, fourth, and fourth. And then for each clock, you look at your input, which is the SR. 0 1 mean what? 0 1 mean reset. 1 1 mean invalid. 1 0 mean set. 1 1 invalid, and then invalid. When you talk about invalid, sorry about here, invalid is supposed to go back to 0 because it's invalid. Yeah, boy. So that's basically what happened with this kind of question. We're gonna have a look on this question. Now with active low as a latch. Okay, so as I said, it's all about you pick every time there is a change in this waveform, you pick that point to be your reference point. Okay, so you pick this point just to set your clock, This will be your initial state. And then you check again. You can see that here there was also a change. You pick, and this become our first clock. You go, you check, and see here. You go with it up. This become our second clock. So as we said, you have a clock which is our second clock. And now you come again, you can see that on our R, you have another change in time there. So you pick it as well to become as our third clock. And then you look here, you can see again, you have another time. So you pick it to become your fourth clock and then fifth. And this can be done on and on and on. Okay? So after doing this, what do? We work with each clock. For instance, when I come here on the initial, it's gonna depend. If in the question they say the initial it was low, then say you take it at low. But don't forget, this is a active low. So it's the reverse to the first example we did. So when you come here, you can see you have a 0 on the set, a 1 on the reset. With active low, 0 on the set mean what? We set. And therefore you come here, you set your output. And again you move, you look, you can see you have a 1 here, and then you have a 1 on your SR. What's happened? It means it no change. There is no change that will happen. Okay, and then you move on the third clock. You can see that you have a 1 on the set, 0 on the reset. What does that mean? You reset. Okay, and then you move to another column, and then you can see now you have a 1 1. What does that mean? No change. And again you move, you find that you have a 0 on the set, a 1 on the reset. 0 on the set, what does that mean? You set your latches. So that's how you walk through this kind of question. Then the second is gonna be the gate SR latches. A gate latches require a enabled input. Okay, so with this one, what happened now? We have an enabled input, this en. Okay, so this become like a gate. It's like our switch. So we know that with a switch you only want to have two states. It's either open or it's either close. Okay, so this is our switch. In order for our SR latches to operate, this enable must be at 1. Okay, the switch must be closed for it to operate, for it to follow the data of SR. Once it's open, everything will be latches, will be 0. These latches mean 0. Okay, can you see our enable here is how much? It is 0. It is 0. It means the switch to what is open. All the output are what? 0 0 0 0 0 0 0 0 0. Can you see that? Okay, but let's say that now we switch on our switch, which is our enable. We put a 1 on the enable. We put a 1 on the enable. Okay, which means now we have activated, we enable our SR latches to follow the data. So once our enable is at 1, now we can be able to look at the input. Okay, so when I look, I can see this is a active I SR latches. Why active I? Because we don't have any inverse here. If it was inverse, it's gonna be active low, and we know how to make the difference between the two from the previous example. Okay, so therefore when I look at, I have a 0 0 0 0, it means what? No change, né? Okay, no change. When I have a 0 and a 1 on the reset, it means I do what? I reset. Can you see that? As we explain it. But in order for us to follow this combination, we need to check and see that our enable gate is it on 1. Once it's at 0, we don't follow anymore the data. And then when you come here, you say, my enable is at 1. Then I check here, I can see I have 1 and 0. 1 on the set, 0 on the reset. It means what? It means set. And therefore, once you look again, you see on your gate it's 1. And then you see 1, 1. It means what? Invalid, huh? Yeah, boy. It's invalid. Invalid, it means we're gonna get a 0, 0 there. Okay, so that's how we operate with this get SL latches. Okay, and therefore, in order for this, as we said, the latches will not change until the enable is high. Okay, from as we explained, until this guy is 1, nothing will happen. Everything will be equal to 0. Okay, and then 4, we can move. Another point we should keep in mind is that the output is controlled by the state of the SR input. It's controlled by that because once this guy is 1, now we can look at our data. And then we're going to do an example as well on our whiteboard. And then we're going to do an example on this question, which is a get CR latches. And as we said, the most important part of the circuit is our enable. So we're gonna look first of all on enable. Everywhere where we have a 1, this will be the place where we are going to consider our input data. So you come here, you pick. Can you see? So between this green line is where you guys you are going to follow the input. Everything outside, it's already 0 because the enable is 0. It's a open switch. So everything out here already become 0. Can you see? So now you have removed a lot of work just in one step. You look at the place where your enable is high. Okay? Then after doing that, now you come, you can check now, you put your line to make a clock. And then you can call this one to say, for instance, our first clock. And then you come here, you say this to be our second clock. You come again here, you pick this point to be your third clock. And then you have this clock here, sorry, to be your fourth clock. And then you come here, you can pick this clock to be your fifth clock. And then you come, you pick this point to be your sixth clock. Okay, so you start on your first clock here. Okay, this column. So when you look at this column, as you can see, is a active high asset latches. You have a 0, 0. What does that mean? You have a no change. Okay, and then when you come, you look, you see 1 on the set, 0 on the reset. It means what? Set. Then you set. Okay, and then you move on the next column, you check, you have a 0, 0. What does that mean? No change. And then you come, you check, you have a 0, and then you have a 1 in this column. 1 on the reset. What does that mean? You reset. and then you come again, you can see you have a 1 and a 0 in this column. What happened? It says it state. You set it. And then you check in this column, as you can see, you have a 0 on the set, 0 on the reset. What does that mean? No change. And then when you come here, you can see that you have in this small column, it's 1 and 0. What does that mean? No change, and then it went back. Can you see? So the enable gate, this is like a gate which allow us to follow the data. Everywhere where our enable it's 0, like this part, you have a 0 there, a 0 this side, which means already on the input, already you're gonna have a 0 output there and a 0 output there. We follow the data only where our enable is 1. And then when the last one, when it comes to the gate D latches, the difference, it's different from the SR latches because it has only one input in addition to the enable. Okay, so this guy, as you can observe, it only has one input, and then we have that enable switch that we discussed in the previous video. It's like a switch, so we only have one input data and the enable switch, and therefore the input is called the D as data, and then the output Q follow the input D when our enable is high, when our switch is closed. Okay, so let's come and look here. When our switch is 0, what happened? We can see that it latches, it means it's 0. We don't have any input because the switch is already closed, it's open there. So by the time we come and then we enable, we open, we close our switch, we give a 1 1 to the enable. Okay, so now we can follow the data. When our data is 0, our output become what? 0. When our output data is 1, our output is 1 as well. But this depends on the switch. If the switch is closed, we're gonna get some data. But when it's closed, everything will be 0. It's gonna be latches. So we're gonna do an example as well on our whiteboard. So when it comes to a D gate, the gate D latches. So when it comes to the gate D latches, as we say, it's all about the enable switches. So we look at the enable everywhere where we have a I, we draw it like that, and then you can come here, you see again here, a enable is only there, it's higher there, and it's higher there. Okay, so what does this mean? It means our latches is only operating in those cases where you have a 0 here. Already this side it's gonna be reset because there is no any data, it's 0. Okay, here you have a 1, you keep it. Where you have a 0, already this one will go to 0, and then that side, as you can see, you have a 1 in between here, but there outside it's gonna be 0 because you have a 0 there, a 0 there. Already this gonna affect our output. This is going to affect our output. Okay, because we say a enable is our switch, so we need to make sure that a enable is at 1 in order for us to read our data. So where we have a enable as I, then we check at our data. We can see here we have 1, then we check at our data. So you can see our data is 1, therefore our output will be 1. And then we move on the second point. We can see that we have a 1 here. So then we check our data. So our data, you can see that in this case it's play around. Then we can split it as well, the way it play around. Okay, so as you can see, you have a 0 on the data, which means the output will be what? 0. You have a higher on your data, which means the output will be what? I. And then you have a 0, which means your output will go. So that's basically how you play around with this question.